Hi, good morning. As Krista said, I'm Jakubiec. I'm one of the developers of DIVA, and I just wanted, we released a new version. I wanted to share it with you guys first in a way. So in 2012, we had our DIVA day, and we got a lot of feedback from the various participants in that. We always constantly get feedback from the members on the website as well. So we've tried to incorporate some of the suggestions, although not all, into the new version. And I'm just going to go straight into some of the more major new features that might be interesting. This one especially for consulting engineering firms. So when you run a grid-based radiation map, before, if you know about the method behind it, use the so-called cumulative sky method, which basically sums up all of the skies in the year and says how much radiation do you get, but you can't break it out by hour or by time of day very easily. And one thing we got a lot of requests for was to be able to do it in another simulation software besides pure radiance, which is DaySim. And the benefit of doing it in DaySim is that you get hourly results. So you can run a radiation map grid. In this case, this is a unshaded kind of window system and a shaded kind of window system. And you see the results visually. I mean, that's what you can do already in DIVA. But now when you do it with the DaySim-based method, you get basically an hourly Excel file or a comma-separated value file of all the irradiation values in watt per meter squared. So then you can actually do spatial analysis. Here I just plotted like the z-coordinates of the shaded system versus the maximum irradiation in watts per meter squared. So then you see exactly what the peak irradiation is, and you can identify the time of day and really go into the irradiation data more than just looking at the cumulative. And this follows that you can, within DIVA actually, when you load in metrics, you can also select a point, and it will false color annually, just to get a quick overview of the irradiation distribution of that point. So in this case, you see the shaded system really is only getting direct sunlight in the mornings and afternoons in kind of January and November, December. And the unshaded system is more entire day irradiation all the way up to April, and then all the way from like the end of August to the end of the year. And so how that's used, I mean, it really depends on your project, but it should be something that could be pretty useful. Another just usability improvement is that when you load in grid-based results now, it always tells you the minimum and maximum of the scale that of the data in the file. So if you're loading an luminance file, you're probably used to it saying 300 to 2,000 lux. But now you'll see, well, actually the range in the result file is actually between 0 and 70,000 lux, and that's just because direct sunlight is hitting into the space there. So usability thing. We have also renamed the results folder to the DIVA folder, and that's just because there's a few more things going on inside there now. So whenever you click the project setup location button, it's going to create an individual material.rad file that's project specific. So if you had a project in Canada and you needed to put specially dark glazing because it's a solar controlled glazing, you could put it just into that file and not into your main DIVA material file. Also, it's going to keep all of your daylight coefficient files from climate-based metrics, your annual comfort results. They'll all be stored in this DIVA folder. So if you need to migrate a project from one computer to another, you can just copy the project file in the DIVA folder, and all of those long ray trace results from DaySim, or the really long annual glare probability comfort results will come along with your file from now. Just a couple of other notable changes that I didn't think necessarily deserved their own slide. Radiation map visualizations can be run for all the saved views in the file, so if you've been having to run them all individually, that's a bit of a break now. Actually, this one is kind of big. You no longer have to, the Python no longer installs separately after you run the DIVA installer. It actually, we install Python now in the DIVA folder. So if you're on a corporate network and you've had problems with your IT, they only have to give administrator permissions to one directory now. And the installer can be run completely silently if you don't have to pop up Windows. We've added a cleanup function to the DIVA temp directory if you edit the simulation files that come out of DIVA for your own purposes. The directory is much more navigable now. There's a whole bunch of bug fixes, and error catching, and all that kind of stuff that I'm not going to go into, but you can of course read about it online. And as Christoph alluded to, it's actually available for download right now, just from our download page, and the change log, you can click on it right there and really see everything that we've changed. I don't know if anyone has any questions about that, but I'm actually giving the next presentation as well. Well, thank you. I would answer any questions that you have.
Actually, the big thing is that you see what Austin showed. You only have to run now the radiation map once, and you can then, without rerunning it, take monthly radiation. You can take ratios if you want the solar heat coefficient of an entire facade, so it makes it very usable, interactive, and powerful.
Yeah, that's true. I didn't mention that, but as Chris said, when you run this annually, once you've done it with the DaySem method, you can reinterpret the annual results without having to rerun the simulation. So if you run it annually, then you could do winter, summer, morning, afternoon, without having to, very fast, basically, and display them. Actually, I could